If you're new to CNC machining or thinking of purchasing a CNC machine, you can't afford to miss this video. I'll show you how to enter a file into V-Carve and turn it into G-code to run your machine. Then we'll load the code into the machine, run an air cut to check that everything will run as planned, and then run the program. You'll not only learn CNC basics, you'll have a great finished project, a raised dog bowl stand. And if you don't have a CNC machine, you can still make this project with a scroll saw or a jigsaw. I'm excited to get started. I purchased the files for this project on Etsy, and I'll leave a link to the source in the description. I'm starting with one end of the raised stand, and the other will be identical. I opened the file in V-Carve, and I'll use this software to create the G-code files to download to the laptop controlling the NextWave Shark CNC machine. The X and Y dimensions are okay, so I left them as is. If you want to start using a CNC machine, you must consider more accurate measurements than you may be accustomed to. I posted a chart like this outside my CNC enclosure that converts fractions to decimals. You'll need decimals to enter the X and Y dimensions correctly. If you don't already have one, you need to buy a caliper to measure material thickness. I'm making this project from 4/4 oak, and the thickness of S2S hardwoods varies from 13/16 to a full inch thick. If I used a ruler to measure this board, I would have decided it was 3/4 thick, but the calipers gave me a thickness of 0.73 inches. I'll cut through the board and into the spoil board on this project, so that measurement must be accurate. I'll cut the paw print before I make the exterior cuts. Like making projects on the scroll saw, you should always make the interior cuts first. I moved to the toolpath tab, clicked it, and the menu for toolpath choices is now visible on the right side of the screen. Cuts that go all the way through the material are called profile cuts, so I chose that option. I like to set the Z-axis to 0 at the top of the material, so that setting is okay. I measured the board's thickness at 0.73 inches, and I want the cut to go all the way through, so I set the cut depth at 0.76. I'll be using a 1/4 inch downcut end mill bit, but that choice was already set. Profiles are most frequently made outside the cut line, but these will be inside, so I moved the check mark to the appropriate box for that option. A wrong setting here would completely ruin the cut. I don't need tabs for this pattern, so I'll skip that section. The software decided on 11 passes for the bit to make these cuts, and I don't want to overwork the router, so I let that stand. I don't mind if running the job takes longer, as I can work on other projects while the CNC runs this one. I need to name this file before I can save it, so I called it end for medium stand 0.25 downcut. I saw a tip that suggested including the router bit information in the file name. If you make the project again, you'll have the information you need to set up the router right in the file name itself. I selected all the segments of the paw print because they'll all be cut with the same router bit, so they can all be cut without changing bits. I clicked the Calculate button for the 3D view, and you'll notice that a warning message popped up. This message prevents you from accidentally cutting through a workpiece when you only intended to cut part way. Since we intend to cut through the wood, this message confirms that we set up correctly. Now I can save this file. I clicked the Save Toolpath tab and realized I needed to create a new folder to save the files for this project, so I did that and then saved the file. Now I can open the ready-to-control software that tells the CNC machine what to do. The software takes some time to load, which I compressed in the video, because I use an old laptop with a Windows 8 operating system for this task. It's slow, but it works, and I'm storing as many files as possible on a 2 terabyte external hard drive. I found the file I just created and opened it. The software shows what the machine will cut and where relative to the axis 0 points. The red lines indicate where the router will travel, raised above the Z0 set point. I set the X, Y, and Z axes to 0 in the lower left-hand corner for this project. That's my most common starting point, but it will be different when I cut the circular holes for the bowls later in another piece. I didn't have any stock wide enough for the end pieces for the raised dog bowl stand, so I edge glued some 4/4 red oak to create a panel. I needed a board wider than the finished piece so I could fasten it to the waste board with screws in the corners. I used 2 drills to speed up the process. One is to drill the pilot holes and the second is to drive the screws. I built a frame around the Next Wave CNC machine to help control the noise and the sawdust. I installed sound-absorbing panels on the inside of the top and sides, but they didn't deaden the sound enough, so I removed them. The sides and tops do help contain the sawdust, which is more wood chips than dust, so for now at least I'm keeping the enclosure. The next step was to zero the X, Y, and Z axes before I could run the air cut and then start any machining. I plugged the controller for the Shark into a USB port on the laptop, then used the software controls to move the gantry to the left in front of the machine. For this job, I'll set the X, Y, and Z 0 points at the lower left side of the panel. This point will be in the waist area where I drove one of the screws holding the workpiece into place. I used the fast speed to move the gantry close to the final position, and then I switched to slow to make the final adjustments. Once I had the router bit centered over the mark, I lowered it until it touched the surface of the wood, and then set that as the X, Y, and Z set point. It's always a good idea to run an air cut before you start any cutting. This cut is run with the router or spindle off and the tool raised to 1 inch above the Z-axis 0 point, which is the surface of the wood. This means that the machine travels the set path for it in the software, so you can check for any errors before any cuts are made. More than once, running the air cut has saved me from disaster. The machine now knows that this is the starting place for this operation. I ran an air cut version of the G-code to ensure everything was set up correctly. That means the router's spindle is off, the gantry runs through the motions of the instructions with the Z-axis or spindle height 1 inch above where it will run during the actual operation. This lets me visualize what will happen when I power the router on and the bit starts cutting. Everything looked fine to me, so I paused, then ended the air cut rather than let it run the length of the program. This later turned out to be a poor decision. It saved a little time, but created a, thankfully, fixable error. I used the software to move the gantry back to the axis 0 points, and then I reached up and turned on the router. I'd already set the proper spindle speed for the 1/4 inch downcut bit I selected for this project. There was a slight delay, and then the router moved to the starting point for cutting, still 1 inch above the wood's surface. There was another delay, then the router slightly lowered into the wood, began cutting, and the gantry moved the bit in oval shapes to cut the paw print design into the stand's end piece. With the paw cut completed, I'll go back to V-Carve to set up the toolpath to cut the outside dimensions for the dog bowl stand's end. The same board is still set up in the CNC machine, so I don't need to change any of the X, Y, and Z dimensions. I closed the toolpath for the paw print and selected the toolpath for the end's outside dimension. Once again, the dotted lines indicate the area I've selected. I opened the Toolpaths tab on the right side of the screen and chose the Profile tab once again. The depth was set for 0.76 inches the first time, and that barely cut into the spoil board, so I increased the depth this time to 0.77 inches. But this time I wanted the vectors on the outside of the line, so I made that change. I'll add tabs this time because I want that end piece to stay in place until I complete cutting. Without tabs, once you've cut through part way around the perimeter, there isn't enough material left to keep the workpiece in place. The router's movements can cause unwanted workpiece shifting that will ruin your work or even send it flying off the machine's bed. Either event can ruin your day. I added 6 tabs, and the software showed me where they would be placed. The locations look good. As before, I named the file and then looked at the 3D view. I received the expected warning that I would cut through the material. The blue line showed where the cut would go, and I was a bit puzzled by the shape of the cut on the left side of the arch at the bottom. I never did figure out where it came from or how to correct it, so I left it there. It will be easy enough to trim off later. I saved and closed the file. I returned to the Ready to Control software for the CNC machine, deleted the file for the paw print, and opened the file for the outside cut. It looked good except for that odd area at the bottom, so I ran the air cut to look closer. I watched the machine make the air cut and thought the router bit got very close to the board's bottom and sides, but it still looked okay. I moved the machine back to the 0 points and reset the file to start running from the beginning in cutting mode. I'm new to the CNC process, so I like to watch the machine run through at least one cutting pass. During the first pass, I discovered my first mistake. I used 4 screws, one in each corner, to hold the workpiece down to the spoil board. I thought they were placed outside the cut, but the screw nearest the 0 set point was not, and I hadn't caught this during the air cut. The router bit touched the edge of the screw during the first pass, so I paused the program and moved the screw to the middle of the bottom edge. Thankfully, the router bit wasn't damaged. Now I can admit my second mistake. This panel should have been maybe an inch wider. You can see that the cut on the right side has a small amount of waste on its outside, but the cut on the left side is a bit beyond the blank. I let the program run because the dimension was close, and I thought I could salvage the part. After all, the paw print was fine, and the right side, top, and bottom were all okay. I found out later I was right to continue, and I was able to salvage the part. This zoom in will show you 2 things. First, notice that the router moves up a bit, continues to cut, and then goes back to the full cutting depth. This is the CNC cutting the final tab. Then when the program reaches its end, the router is lifted to the Z plus 1 inch position, and the gantry stops at the X, Y, 0 position. I reached over to turn off the router, and then I used the software to move the gantry as far back as it could go to make it easy to remove the workpiece. I removed the workpiece from the CNC machine and moved over to my Pegas scroll saw with a number 9 Pegas modified geometry blade to clean up the edges. The .77 depth wasn't enough, so the perimeter was ragged, and there were 6 tabs that needed to be cut through anyway. I started at the lower right corner and cut across the bottom, making the correction for that odd shape on the left bottom. I still couldn't figure out how it got there. I reached the left side, then continued cutting up that side, across the top, and down the right side. I learned some valuable lessons making the first end, so the second went without a hitch. I let you see the errors so you know that making mistakes is almost inevitable when learning new skills. I opened the V-Carve software again to create the file for the circular holes for the dog bowls in the stand's top. I have to get creative setting this up because my machine is so small. The stand's top is 18 inches long, but the Shark 100 will only accept dimensions of 13 by 13. The X dimension is okay and can be entered as is, but since there are 2 bowl openings, one near each end, I'll enter the Y measurement as 9 inches, half the actual length. I measured the thickness with a caliper, and it's 0.80 inches. Now I need to create this circle opening, and that's a simple task. There's an icon for creating circle vectors, so I clicked on it. I experimented with opening sizes on some plywood, and I decided on a 5.75 inch diameter hole. I'll set the XY center point in the middle of the workpiece and tell the software I want a 5.75 inch diameter circle with the X and Y zeros at the center of that circle. Then I moved to the toolpath tab and selected a profile cut again, since I'll be cutting all the way through. The cut starts at the surface, so that number is correct at 0. I thought about it briefly and decided to set the cut depth at 0.83 inches. I measured the material to be 0.8 inches thick, and the 0.03 will go beyond the wood and into the surface of the spoil board. We want the vector to be cut inside the line. This is one of those boxes you must always ensure is correct, or you could ruin some material. I selected the vector and added 4 tabs. They'll be added at the circles 3, 6, 9, and 12 o'clock positions. We'll have the cutting start with a 2-inch ramp to save some wear and tear on the router and bit. Otherwise, the bit will just bore straight down and start cutting horizontally. As before, I named the file to note precisely what it would do and what bit it would use. The warning tells me that the bit will cut through the material, which is what I want it to do. The 3D view shows me that the tool will cut a circle. Lastly, I save the file in a folder where I can easily find it and open it with the Ready to Control software. I opened Ready to Control and used the software to move the gantry to the place on the wood I marked as the center for the circle I would cut first near one end. After I cut this opening, I'll flip the board around to cut the circle on the other side. I have to do it this way because the machine can't handle anything over 13 inches long or wide. I loaded the file I created for this, and I'm going to run an air cut. The software shows what motions the gantry is performing, but what I need to do is watch the machine to check that there will be no problems. I used 2 F-clamps to hold the workpiece down, and I need to see that the router will clear them, so the air cut is an important step that shouldn't be skipped in this project. I saved the X, Y, Z 0 set points at the center of the circle I wanted to cut. The router might get a little close to the clamps, so I was a little nervous about the setup. When I ran the air cut, the machine cleared the right side clamp and barely brushed against the handle of the left clamp, so I decided the program would be okay to run and I could leave the clamps where they were. I stopped the air cut and moved the gantry back to the 0 set points. Letting the machine run at least 2 revolutions around the circle probably would have been better, but I was anxious to get started. I shifted from air cut to normal mode, and the machine did exactly what it was programmed to do. As I was learning CNC basics, I read, "The good thing about CNC machines is that they do exactly what you programmed them to do. The bad thing about CNC machines is that they do exactly what you tell them to do." In other words, it's up to you to determine that the job is programmed and set up properly. I was working on other projects, but kept an eye on the machine while it ran and ensuring nothing went wrong. At one point, I checked the clamps to guarantee they were still tight. The vibration of the router could cause them to loosen, creating a big problem. The clamps remained tight, so I returned to whatever else I was working on at the time. As the router neared the end of the program, I stayed close by and watched the last couple of passes. It's a bit mesmerizing. You'll notice that on the last pass, the router races slightly, moves partway around the circle, then dips again. This is the machine making the tabs that will hold the material in place, then cutting all the way through the rest of the workpiece and into the spoil board. I like to be standing by for this final part of the process. At the program's end, the software automatically returns the gantry to the X, Y, 0 and 0 plus 1 inch positions. I turned off the router, moved the gantry to its farthest back position, and removed the clamps. I checked the bottom of the piece and noted the router cut through the wood and left 4 tabs, just as I had programmed it to do. I'll take this to the scroll saw to remove the waste piece, and then I'll flip the wood around. It's finally time for assembly. I already have the first end glued up and clamped, but I was blocking the camera for most of that step, so I'll show myself adding the second end. No Hollywood director has to worry about me threatening to take their job. One side had a very small amount of tear out along the edge, so I ensured that side was on the inside where it would be hidden. I squeezed a bead of glue along the edge of the side where it will come in contact with the end, and along the end piece where it will touch the side. I used my fingertip to spread the glue out evenly. Then I carefully aligned the end and added 2 long F-clamps. The end is angled, but the tips of the clamp are flexible, so they make good contact. I tightened them securely to ensure a good bond. I could have left the partial assembly like this to dry, but I wanted to see what the top would look like when it was in place, so I flipped it up on end and tightened the clamps a bit more. I reached over to where the top was sitting and placed it in position. Then I fetched the 2 dog bowls and put them in place. I like the look and fit, so I'll let the glue on this assembly dry for a while, and then I'll glue on the other side. This project was a great learning experience for me on the CNC machine since I'm at the beginning of the learning curve. I'm excited about the possibilities of what can be made with CNC. I'd love to read your comments, and I'll reply to each. Do you have a CNC machine? Are you thinking about buying one? Are there any small projects you want me to do with my CNC? I'm currently editing videos on the ice cream sandwich box and one on wood finishes. They'll be coming soon, but until then, there are suggestions for 2 videos you can watch now on the screen.